So up to this point in the module, we have only looked at hypothesis tests involving means, where we have been checking the plausibility of a specific population mean through hypotheses that have been set up like this. In this video, we're going to continue talking about hypothesis testing, but this time in the context of proportions. So we'll be talking about checking the plausibility of a specific population proportion, P. And so our hypotheses now are going to look like the following. It's going to be P instead of mu. P is equal to some number. Instead of using the number symbol, now I'm going to use P naught. And the alternate would be that true population proportion is maybe not equal to P naught, or maybe it's greater than P naught, or maybe it's less than P naught. And so if we're working with proportions, that means that we're most likely working with this distribution of sample proportions, and we're hoping that's going to be approximately normal. Well, in order for that distribution to be approximately normal, we need certain assumptions to be met, just as we needed in Module 7 and 8 when working with this distribution. And so this looks really familiar right here, this n times p needing to be at least 10 and n times 1 minus p needing to be at least 10. Now to be technically correct here, I'm going to say, I'm going to fix this a little bit. I'm going to say n times p naught needs to be at least 10 and n times 1 minus p naught needs to be at least 10. You'll also see in your notes that I've added a couple of other assumptions, such as the population needs to be at least 20 times that of the sample and things like that. But this is the one assumption that we've consistently seen over the last few modules. So when you're doing a hypothesis test involving proportions, and it's just a single set of data, which is what we're working with right now, your test is going to be 1PROPZTEST. Your conclusions are going to be the exact same as the types of conclusions that we've been making earlier in this module. If p is greater than alpha, remember, large p-value is not good for a scientist or a researcher or something like that, because in that case, you are unable to reject the null. You fail to reject the null. And in contrast, if p is less than alpha, then you reject the null. And when you reject the null, in the context of our examples, we're seeing that you can actually accept this researcher's hypothesis, this alternate hypothesis. Okay, so now let's see if we can apply this in an example. So let's take a look at this problem where I said a Gallup poll taken in December of 2009 sampled 1,000 adults in the U.S. Of these people, 770 said that they enjoyed situations in which they competed with other people. Can you conclude that less than 80% of U.S. adults like to compete? Use the significance level alpha equals 0.05. So as soon as you see alpha equals 0.05, you're thinking, okay, another hypothesis test. And a lot of times I suggest that you look at the question at the end of these problems, because many times that will reveal what the researching hypothesis is, or the alternate hypothesis. And in this case, it's also going to reveal if we're dealing with means or proportions. But when you look at that underlined statement, you see nothing about means. There's no mention of means in this at all. It says, can you conclude that less than 80% of U.S. adults like to compete? Well, a percent is a proportion. They're looking at a proportion of U.S. adults. And so based upon this right here, I know I'm doing a hypothesis test. I know it involves proportions, and I know my hypotheses are going to look like the following. My alternate is going to be that the proportion of U.S. adults that likes to compete is less than 80%. And remember that when you look at that question, it's kind of highlighting the researching theory or the alternate hypothesis. And a lot of times when I have that, I could say, okay, well, the null would be that there is no change from what is expected. And so our null hypothesis in this case would be p is equal to 0.8. Okay. Now, the one thing that I have not mentioned yet is checking assumptions. Before we go to the tool in the calculator, which we know it's going to be 1PROPZTEST, we should check to see if n times p naught is at least 10 and n times 1 minus p naught is also at least 10. But n is 1,000. And so if you took 1,000 and you multiplied it by our p naught of 0.8, you can see that you're going to get a really big number. It's going to be well over 10. The same thing if you did n times 1 minus p naught. Even if you did 1,000 times 1 minus 0.8, you're still going to get a number that's in the hundreds. And so both of those conditions are met. We can go into the calculator. We're going to look at 1PROPZTEST right now. So let's press Stat and then go over to Tests. And 1PROPZTEST is number 5. You'll notice just a few things here. We have P0, and so that's the null value of the mean. The null value of the mean in this example is 0.8. And then X is the number from the sample that satisfied the certain characteristic that you're looking at, and N is the total sample size. And so in this problem, we saw that 770 people in the survey said that they liked to compete, or they enjoyed situations in which they were competing with other people. So my X is going to be 770, and my sample size N is going to be 1,000. We sampled 1,000 adults. But make sure that we select the correct alternate hypothesis. And so I'm going to go to the middle one, press Enter, and then I'm going to calculate. And when I calculate, we get a few things here. So the first thing that we see is a z-value. Now that z-value is what we call our test statistic. So z equals negative 2.3717, etc. This is our test statistic. And a test statistic is essentially how many standard deviations our data from the sample is from our assumed mean. And try to remember, when we do hypothesis testing, we always assume the null to be true. So if this is the distribution of sample proportions, and we're assuming our null to be true, then 0.8 is our mean. Well, in our sample, we had 770 people out of 1,000 who said that they enjoyed competing. And so 770 out of 1,000 is 0.77. And so, first of all, if we looked at the area to the left of this, that is exactly going to be what our p-value is in this next part. But the number of standard deviations that 0.77 is from 0.8 in this distribution of sample proportions is precisely what this z-value is right here. So if this distribution got standardized, 0.77 would get converted into a z-score of negative 2.3717. And like I said, the p-value is going to be this area, and we could see based upon our test results that the p-value ends up being 0.0089 if we're going to 4 decimal places. And since that p-value is lower than our alpha cutoff of 0.05, we will reject the null hypothesis. And if we're rejecting the null, then we can accept the fact that the proportion of U.S. adults who like to compete is less than 0.8. So the percentage of U.S. adults who like to compete is less than 0.8. Okay, so that is basically it for hypothesis tests. Hopefully you're comfortable with the structure now. You understand that we need to decide if are we doing a test for means or proportions. We need to check some assumptions. We need to establish hypotheses. We need to find things like these test statistics, but primarily we need to find things like p-values, and then we need to draw conclusions based upon the relationship between those p-values and our significance thresholds that have been established. So in the next video, what I'm going to do is I'm going to put it all together. We're going to see examples involving hypothesis testing from this whole module, and hopefully that will be good practice for you.